Nice. All right, so let's use the field info and see how deep we can go if we can actually retrieve the database from our property. So field info has the we should be we can probably get the data from the property. Let's see what property has attached. It has a serialized object. That's the object that's being serialized. And does that have a name property attached? And here's the target object. And here's the name. So we're going to print this name out right in our label. So let's do an editor GUI. Property field, no, we just need a label field. Do we even have that? Yeah, cool, we have a label field and we're drawing it at the current position. Come on, we gotta have a string in here. Okay, cool. So that's the label that we're gonna be drawing. That way, that'll tell us what our target object is. And I suspect it would be the actual creator. So from there, we can do a conversion to probably not a mono behavior. We may need to implement an interface so we can ensure that the database can be extracted, if that makes sense. So let me go on and then we'll see. Let's run that and pull a few items off this thing here. It's the only way to know. So here we have piece creator and slab creator. So that's our serialized object. So now there's no way of really knowing without using reflections, which we can do, but I mean, there's a lot of work in doing that. So the easiest way, and probably a way that will benefit later on as we code the database interactions, is to define interface that guarantees that we'll get at least the database back from the object, right? So let's go into our interfaces. I have some here. All right, let's use this interface, and maybe naming again is a problem. So I'm gonna stick to something simple. I has database. So I has database. You know, if it's it's not supposed to be proper English. It's just a definition. So we need to get the database. We're not going to be assigning to the database, so we should be fine with what do we want? A scriptable object. Our database contains a list. This is what we want from our database, all right? So we may need to traverse the interface tree a little bit interface tree a little bit deeper, because once we identify we have a database, how do we extract the identifier from that database? So we may need to go a little deeper. So now that we know we have a database, let's see how we can get the information from the database. So let's just do I has database. So I has database need to return a slabs database It can't do that because we have a slab database, we have a piece database, and presumably in the future we're going to have a pickups database, which may very well all be collapsed into a database collection. So we can't depend on the actual database itself. We need to depend on commonalities that are within the database. And the only commonality I'm seeing now within the database is a list of items. So here we have a list of slab data and a list of piece data. So that's why I was thinking about maybe the data themselves need to be identified as being database data. So because right now we have no way of pulling the data out, because what we know for sure is all of our databases are scriptable objects, and that's all we have to go on. So let's get some namespaces in here. So that's all we know, and we can, I guess, I like properties. So let's see how we define our, so we have it defined as in a lowercase. Okay, so let's just use and we do a get. I don't foresee any reason we're gonna need a set. So how's about one of them there thingies? So how about that? I think that might be an answer to our problems. A generic. No, because we still won't be able to tell what type of data we have unless we have some way of identifying it. So I'm gonna put that on the back burner, and we'll step through the process of solving it the problem one at a time, one step at a time. So let's start here. So we have a IHAS database which says that you have a scriptable object contained that I can access. Explicit implementations, perfect. Well, no, let's do just the implementation. We may need access to it in other things. As I did the explicit implementation, I thought about accessing it outside the class and performing other things with it and make it more useful. So let's keep it at public. So let's return. So there we go. That's what we're returning for now. So the generics may offer us a better option. So let's continue along this path for now. Oh, sweet. Diamond Rose, are you still on? We'll pull up that browser. It's past an hour anyway. I need to stand up and stretch the knee. Oh, Quantum, later, man. Didn't see you were leaving there. Thanks for coming by. Yes, it's always happy coding. Most definitely. Yeah. So we're implementing our interface. So it says 120 here. I gotta get up, keep the knees stretched and stuff. So I'm gonna take the 10. When we come back, we'll implement this interface, and it's probably gonna need to be generic so we can grab exactly what we need. All right, minus what? Yeah, Hayden, I was over there checking that out. That's a lot of cubes, even for primitives. If they change into prefab, how do you change them into prefabs? Do they all have a script attached to them, or are they Ooh, what's going on? No drops. Okay. Yeah. Do you have a script attached to each of them, or HD? Welcome. What's going on? Or are they the prefabs replaced by another script, a manager of sorts? Okay, so we do have access. We know who this is, and we can convert now. Actually, we're using them both. So we can say you has a database, and we can also identify our piece creator as having a database. I love my English. So that's my coding English. So you has a database too. Oh, look at that. That's another opportunity there. Alright, so now let me clean this up here. Give myself some room to think from line to line. Okay, so now we know that they all have a database. Let's try a conversion and see what we get out of that. So we no longer need our attribute. It's night. What's your time there, HD? Are you East Coast of the U.S.? I think I remember you saying you're in the U.S. So what do we need open? We don't need our copy. There, we have access to our data now. So in our drawer, oops, this is named wrong. That's why I closed it. It's in a different namespace, so it doesn't bug it. Well, now that's better. So now let's try to cast that. So I has database, which is in did I do something wrong again? Hang on. Did I rename the file? I did. It's in Boulder Run, and I has database. Okay. I has database. Okay. What am I missing here? I am an interface, but I do not have a modifier, so it's presumed internal, so I won't be able to access it in the Unity editor namespace. These are two different assemblies. Okay, so let's make this public. There we go. So now we have access. Cool. So now let's try a cast. Has equals our target object. So for now, we're only going to concentrate on one. Of course, we can do, or did I copied too much? We can use the target objects, which has an array. But for now, we'll concentrate on one. As I has database, I has custom menu. That's a Unity thing. So Unity likes my English too. There you go, Unity. One more reason I like them. So if that's not no, you know how to do sometimes. Actually, yeah, I do. The short of it is you can. Well, obviously, I'm not going to be typing while I try to explain this. You can define a space around the alien where you want to detect whether it's going to collide with something and start recording when it reaches that space or that distance. Or you can be recording the entire time and only save the tail end of the recording, like however many frames you want. I actually made a recorder, a transform recorder, so it records everything about the specific transform, stuffs it in a scriptable object at runtime. So while things are running, it's recording the data. So you can use something like that. So create a scriptable object, replay, that records the vector for the position, rotation, and those type of things. And I don't know about the actual ragdoll effect if you can record that. But yeah, create a scriptable object because you can save the data into and out of it at runtime. So they're really neat for that, and you can save all the positions and stuff on the transform. Attach that to your replay thing and just keep a count. You know, maybe 100 frames, and just keep dumping the last frame. So it might need to be coded a little with care to preserve cycles, but that's how you can do it. That would be my first instinct on doing it. So depending on how far you want to go with the game, Unity has a free Everplay, Everyplay or Everplay. I can't really ever remember what it is, but it's an asset that records your games, and you can replay the entire game. It's just really easy, plug and play, maybe 2 or 3 lines of code, or create a mini function in your code, and it takes care of all the recording and all that stuff for you, and updating, and sends it to Everyplay and stuff like that. So you may want to look into that option too if you don't want to have to deal with. I'm sure Everyplay recording probably takes a less hit on your game than the code that you can write. So that's the 2 part. So the updating codes that I have for recording, I started screwing around with it, trying to make it into something that I can export, and I don't think it's operational right now. But that's how I did it. It was sort of like the network transform, if you're familiar with that component. Not using it, but just familiar with it. It just records positions. Now I'm thinking about Unity has a tutorial on that on their learn site, and they have a little racing game. They kind of use, like, they race around a urban type area, and then it records a ghost of the last play, and while you're playing, it shows the ghost of that last play. And it's the same type of system that I built. So there you go. Replay, record away. There's a streamer, Hardly Difficult, was Hardly Sober. He built a replay system that records in file positions, but it turns out to be almost the same thing as using the scriptable object, because you get to define what values you want to save. So recording the values is recording the values, and I would go with the scriptable object version of it. So there you go. Back to coding. So if we have a database, we say yes. If we don't have a database, we do other things. So what can we get off the database? We can get that, and that's the database. How do we see? Yeah, see, database gives nothing. So on the database, we need a way to access this, the list of pieces, and let me get these close together, and the list of slabs. So the database themselves, like I was thinking earlier, needs to implement their own interface that exposes those fields. There's no other way of knowing what's attached other than reflections to a scriptable object. Unless we go with the this one here, because that would definitely tell what type. Actually, let's do that. So now we see at least we can't get any information, useful information, from our drawer, right? So if we type in has database, we don't get any information. Oh, okay. That's a failed thought, and this is why. See, streaming takes a lot out of me because I have to talk my thoughts. Normally, you just sit here in solitude and listen to some music or some YouTube in the background. So if I do this, if I make this generic, and I think you can actually have them both, I still won't be able to tell what type is coming off without reflections, because you would still have to define the generic version of it. So that's not good. So each database themselves need to expose their objects. So how about I has I has identifier. Bear with me. I know that the I hases are a little bit crazy, but it seems to make sense. So I has identifier says yes, I has identifier, and this is where we can define what type. Okay? So the type of object you're going to return is a list, whoops, of T. Okay, that's your return value. And we can just call this data. We can return that. So let's boo language. I always laugh at that when I see that. So our piece data has identifier, but it's just a plain old class. Oh, it needs to know what type. Okay, so you say you are a piece. You have an identifier of string. And again, that's not where that goes. That would go here. Okay, now let's implement that, see how that goes, and let's return this. It's trying to gain access to the underlying data in the database. So now each of these databases we'll say they have identifier, and this is their identifier. Okay, now slab data, I can't do that. Oh, it's internal. Since it's tiny, let's just leave it in here. That's like all the data that's in here. So I don't want to make it feel so bad. So here we are. Let's return our data. All right. So maybe we're a little closer to capturing the information. Okay, so I has data, database. Now the databases themselves, hang on, let's get here. Here's the database. The copy, or the creator, has the database. Yeah, we'd have to go deeper into that. So maybe we can convert the database to an IHAS-data, and let's see, as IHAS identifier of any type of class. I guess it doesn't really matter. They probably won't let me do that. Oh, really? Look at that. Now if this, hang on, look, our data, but it's a list of objects, so we're still a little lost there. So IHAS identifier would be a list of string. I got it. All right, think out loud. I got it. I think I got it. So we're going to return a list of strings from our data. All right? So we don't need to know if it's a piece data, and we don't need to know if it's a slab data. We just need to know that you have an identifier, and you're going to return that identifier to her. And the identifier is a list of string. A list of string. Maybe we should go with an array of strings. Right? Yeah. It's going to be an array of strings. So let's do that. So we're not going to use data. We're going to actually return identifiers. How about that? Okay. So that looks good. Yes, it doesn't matter if we return a list. I was thinking about processing. Arrays are always better to return, but we still have to incur some type of processing. So we'll leave it at that. And here's our getter. And let's go into our new has identifier. And we don't care about the type anymore because we know it's going to be a list of strings. Yeah. That just hit me like a lightning bolt. Let's just hope it works. So I like link. I'm going to use link to grab my objects out of here. So we get the slabs, and this is the same thing as, let me type it out and then we'll show the comparison. So we take X and we just X.identifier. Right? And then we convert that to an array. So now the database is responsible for returning the identifiers to be displayed in the list. Right? So internally, the database always knows what it can and can't do and what its data is, but all we're requiring is a list of strings, because that is all we actually need on the back end. And this particular method we can implement explicitly. Right? At first, the other we has database, so we can get the data. We implemented that implicitly. So now we're going to do an explicit implementation, because this is only ever going to be required or used in the property drawer, and it's going to be referenced as an identifier. So it can be just local to the class unless it's used as this actual type. It's just another layer of protection in your code. There's all sorts of things you can do, man, in the code. So this is no bueno. So we do have an identifier, and it's erroring out on us because we don't use that, we use this. So system link, anyone? I don't know how many times I say this. I probably say this every stream. It's by far my favorite library. Or because I use it on almost every stream. Okay, so now they all has identifiers, and regardless to what type it is. So we know our database, each creator, or even a mono behavior. This lives in our editor scenes, so that's why I said mono behavior, which I meant was even mono behaviors that exist in our runtime that we actually use in the game can say they have a database, and they're able to pull the database. And specifically, if you go into the slab manager, the slab manager uses the database. So here we can say also it has database, and someone else can grab the database from the slab manager just by referring to it having database. And we can cast it here locally. As a matter of fact, I want to see if a cast would be a problem, because we know we get a scriptable object out of this type. Right? This may be where explicit and implicit implementation of interfaces will come in handy. So for instance, right now we're good. We did implement our recommended member, but we still have an issue here. It's saying we didn't. So now if we explicitly implement the behavior, we'll always be able to return a scriptable object when something's casted to an IHAS database, and the data will be sound. So for instance, here we'll be returning this, and here we'll be returning database. So let me just code it out. And this will force the reference here. And as you notice, then we have no problem with our interface implementation, and we have access to our database. So that's how explicit and implicit implementations can be used from your interfaces. So I'll just leave this in here. Actually, we'll get to it if we ever need it later. That's just how it works. So now we know we have access to our databases. Let's get back over here. Yes, you have identifier, and our data is, what do we got? So has identifier. What did I do? So let's get that. So if we has identifier, our identifier has the list of array of strings that we need to use I'm looking for my editor. Okay, right here. So we require a list of strings for our display options. So this is the step that we just did. So now on to the next step, which is selecting the index, the last index, and then presenting the data in the pop-up. So let's go ahead and grab this, go into our drawer, and instead of drawing this label field, let's start parsing this into usable data. So our display options is now the identifiers that we selected. Okay, let's move on. The index, if you remember that the property that's tagged as a database key is an index. It's an integer. Let's go into our database, and nope, we need to be in our creators. So here's our two creators, and here's the key, the database key, the selector, for lack of a better term. So we know this property that's coming in is this selected index property. Okay, so that's done there. We need a label, and the label, we need it to be unique, so we can actually just use this label. I don't know if we can use this property. So okay, if we use a GUI content, this reads, if we use a GUI content for the label, that's what's coming in here, our display options need to be GUI content. So we'll just get the text off the label, and then we can use display options of text, of strings. Okay, so we're almost finished pulling all the data off. We certainly don't need that call anymore. So now we reads the same as before. We need to do our checking. We can actually see if this works now. How about that? So we should get a decent drawer there where it says slab creator in our field. And if all goes right, it should contain the data. So here it says selected index, and it contains the data. So if we go here, we have selected index, and we have no data. Or do we? So we have two pieces of data, and they have no identifier. So let's just give them a name. So this piece is hump. Why not? And this piece is bump. So we go into our piece creator now. We have the two selectors, hump and bump. So sweet deal. This works, but as we can make clear here, we can't change anything. All right, nothing changes for our identifier. Our slabs are updating pretty cool, because this is the selected index, but this is the actual drawer that we wrote in line in our editor. So we have no changes here, no responses here yet. So that's our editor. I think that's pretty cool. So how do we have a big old empty space here now? Let's figure out why that is. And it's on both of them. Yep. Here's the space. What is this space drawing? Oh man, this is super slick. I did this string drawing stuff before, and it took quite a bit of code to get it done. And with interfaces, lickety split. And look at how neat it is. Man, this is much better. Now I could go back and update code that I have that uses this type of system with. We've recently started a Patreon campaign, and if you like these videos, check us out at Patreon/CalloCreation. Thank you.